Question 51. What is Azure VPN Gateway and when should you use it? Let's populate the short answer. Azure VPN Gateway connects your on-premises network to Azure over an encrypted tunnel, ensuring a secure and reliable communication. And it supports multiple VPN configurations such as site-to-site VPN, point-to-site VPN, VNet to VNet, allowing for flexible and scalable network solution. What are some of the use cases of Azure VPN Gateway? First, you can use Azure VPN Gateway to extend your on-premises network to Azure. This will allow you to seamlessly integrate your existing network infrastructure with Azure, providing a unified and secure environment for your application and services. Next, Azure VPN Gateway enables secure communication between VNet to VNet communication. This is going to establish secure VNet connections, allowing different Azure virtual network to communicate with each other as if they were on the same local network. And finally, VPN Gateway provides remote users with secure access to Azure resources. And this will allow remote employees or clients to securely connect to Azure resources from anywhere in the world using point-to-site VPNs. Let's look into question number 52. It's a scenario-based question. Your company wants to deploy a web application with high availability and application level traffic routing. Example, URL-based routing. What Azure services would you use and how would you design the solution? I think 3 questions ago we talked about benefits of 2 different services. I'm sure you can guess that by now. I'm going to populate the short answer. The correct answer is Azure Application Gateway. So for this scenario, you should use Azure Application Gateway with Web Application Firewall as an additional feature. Azure Application Gateway, like I mentioned before, it's a layer 7 load balancing and support URL-based routing, SSL termination, and session affinity, which are critical for deploying high availability web-based application with precise traffic routing. So how do you design this solution? So let me help you understand this clearly. So what you can do is you can deploy 2 or more web application instances in Azure App Service or VM to ensure redundancy and high availability. And then you can place the web application instances behind the Azure Application Gateway to leverage its load balancing and routing capabilities. Third, you can go ahead and enable Web Application Firewall or Application Gateway to protect against common web vulnerabilities and threats such as SQL injection and cross-site scripting. Additionally, you can go ahead and configure Health Probe on Application Gateway to continuously monitor the health and responsiveness of your web application instances. Beyond that, you can go ahead and implement SSL termination at the security level at the application gateway to offload the SSL decryption work from your web application instances. And then you can utilize URL-based routing to direct user traffic to different backend pools based on the URL path. When you do this particular setup, this ensures high availability, advanced routing, and application level security. Let's look at question number 53. This is a multiple choice question. Which of the following services provide centralized, fully stateful network traffic inspection in Azure? So let's go through this one by one. Is it Azure Load Balancer? No, Azure Load Balancer is a layer 4 service. It is not fully stateful. Is it Azure Application Gateway? No, it's a layer 7 service for URL based routing and web application firewall. Is it Azure Firewall? Yes. Azure Firewall is the one which offers stateful traffic inspection and filtering for both inbound and outbound traffic along with threat intelligence integration. And this service provides robust network security for Azure resources. Some of the key features of Azure Firewall include, like it is mentioned in the question, like stateful traffic inspection, threat intelligence. It is fully managed, it is highly available, and you can have application and network rule connections as well. The last option is Azure VPN Gateway, that is for connecting from your on-premises to Azure for secure connectivity. That is not the correct answer. So the correct answer is Azure Firewall. Let's look at question number 54. What is network security group? We talked about it a couple of times. And how does it differ from Azure Firewall? That's a really good question. We only talked about network security group and Azure Firewall separately, but we never clubbed it together and looked at the differences. So let's populate the short answer. First, network security group is a network security service in Azure that filters inbound and outbound traffic to and from Azure resources based on rules. How does it differ from Azure Firewall? Let's look into the differences. NSG operates at the subnet or the network interface level because you configure that directly along with your virtual machine creation. This is ideal for any sort of micro segmentation and providing granular control over network traffic, wherein the Azure Firewall is a centralized service offering comprehensive network security with advanced features such as threat intelligence, FQDN filtering, and application level filtering. You can actually go and use it together as a combined feature. NSG can be used for local subnet level filtering, while Azure Firewall provides global protection and centralized management and advanced security capabilities. Some of the high level benefits of NSG include granular control, ease of use, and scalability. And some of the high level benefits of Azure Firewall include centralized management, advanced threat protection, FQDN filtering, and high availability. Question number 55. How can you connect multiple VNets together and what are the advantages of connecting like that? Let's populate the short answer. First and foremost, yes, you can connect multiple VNets together. The methods are either VNet peering or VPN gateway. Let's look into some of the advantages. First, it provides high speed connectivity. This ensures that fast communication between peered VNets with minimal latency. Next, it offers traffic between VNets stays private and secure, which remains within the Microsoft private network, which enhances the security. The third is when you do this peering, this is non-disruptive and maintains the network operational integrity during the setup. And you can enable easy sharing of resources such as databases, virtual machines, and application between these peered VNets. Let us go through database questions in the next section. So we're going to go through 10 questions in Azure databases. Let us look into the first question under database, which is question number 56. What is Azure SQL database and what are its primary deployment options? Let's populate the short answer. First and foremost, Azure SQL Database is a fully managed relational database service that is built on SQL Server technology. It provides high availability, scalability, and security without the need to manage the hardware or database software. What are the primary deployment options available for Azure SQL Database? These are the three deployment options available. Let's look at this one by one. The first one is single database. This is a dedicated database with its own set of resources. Second is elastic pool. In this type of Azure SQL database, this offers shared resources among multiple databases for cost optimization. And the third is the managed instance. This is near 100% compatibility with your on-premises SQL server for lift and shift migrations. So some of the benefits of Azure SQL Database include automated management, so you can schedule automatic backup, updates and patching to simplify database management. Second, it offers high availability. You have built-in high availability with 99.99% uptime SLA. Built-in security features, advanced security features such as threat detection, encryption, and advanced data security. And it offers all sort of compliance you need for regulatory standards such as GDPR, HIPAA, ISO, IEC 27001, etc. Let's look at next question 57. Oh, we talked about Azure Cosmos DB. here it comes. So what is Azure Cosmos DB and how does it differ from SQL database? First, let's understand what is Azure Cosmos DB. Azure Cosmos DB is a globally distributed multi-model NoSQL database service designed for high throughput and low latency at a global scale. So how does it differ from, so before even getting into the differences, let me quickly help you understand what are some of the benefits of Cosmos DB. First, the performance. So Cosmos DB is optimized for high throughput and low latency, making it suitable for mission critical application. Second benefit is global reach. Cosmos DB enables global distribution and local presence, reducing latency for users worldwide. The next is flexibility. Cosmos DB support multiple data models and APIs including SQL, MongoDB, Cassandra, Gremlin, and Table API. Another benefit of Cosmos DB is its scalability. It automatically scales resources based on workload requirements, ensuring consistent performance. And additionally, this provides inbuilt security for your encryption, access control, and auditing, etc. So, what are the use cases for Cosmos DB? Cosmos DB are primarily used for IoT application for real-time processing and analysis, or for personalized recommendation, delivering tailored recommendation to users based on behavior and preferences, or for real-time analytics, performing real-time analytics on large volume of data to gain actionable insights. So now that we understood what is Cosmos DB on a high level, how does it differ from Azure SQL database? Let's go through this one by one. First is the data model. So Cosmos DB supports document, key value, graph, and column family data models, while Azure SQL database is relational database. Second is global distribution. Cosmos DB offers turnkey global distribution with multi-region write and replication. Azure SQL doesn't offer that. Latency for Cosmos DB, it's a single digit millisecond latency for reads and writes. And if you look at the scaling aspect of it, Cosmos DB provides automatic and elastic scaling of throughput and storage. So that's how you can explain what is Cosmos DB and how it is different to Azure SQL database. Let's look at question number 58. Explain the concept of provisioned throughput in Azure Cosmos DB. So let's populate the short answer. Provisioned throughput in Azure Cosmos DB refers to pre-allocated resources measured in request unit per second, which is known as RU per second, to ensure predictable performance for operations such as reads, writes, and queries. This concept allows users to reserve a certain amount of throughput capacity, which ensures that their application can handle a specified number of operations consistently. Some of these benefits of this provision throughput is it offers predictable performance. By provisioning throughput, users can guarantee that their operations will have consistent performance, which is crucial for applications with stringent performance requirements. Second is cost efficiency. The ability to scale throughput up and down and use auto scale options ensure that users are only paying for the resources they need, making it a cost effective solution. And another benefit is high availability of Cosmos DB. Let's look at question number 59. What are the benefits of using Azure database for PostgreSQL? Let's populate the short answer first. Azure database for the PostgreSQL is fully managed open source database service based on the PostgreSQL database engine. It offers numerous benefits and features that makes it a robust choice for developers and businesses. So let's look at some of the benefits of it. Let's look at this one by one. First is built-in high availability. This ensures up to 99% or 99.99% uptime SLA, providing reliable performance for business critical applications. The next is the scalability of it. This allows independent scaling of compute and storage resources, ensuring users to adjust capacity based on workload demand. How does the Azure database for PostgreSQL fare on security? And this provide data encryption both at the rest and in transit, ensuring data protection and compliance with industry standards. Additionally, it provides automated backups. This facilitates point-in-time restore for up to 35 days, offering data recovery and backup management capabilities. And finally, it is hyperscale. This offers the option to horizontally scale across multiple nodes, making it suitable for handling large and complex workloads. So some of the common examples of using this particular service is either for web application. This is ideal for hosting dynamic web application require robust performance and scalability. Another aspect is data warehousing. This is suitable for analytical workloads that need efficient data processing and storage capabilities. You could use this for geospatial applications, which supports advanced geospatial data types and functions. And you could use this for financial services because this provides the security and reliability needed for handling sensitive financial data and transactions. Let's look at question number 60. Compare Azure database for MySQL with Azure database for PostgreSQL. So let's populate the short answer. First, both services are fully managed open source relational database offering, but they support different database engine and communities. So let's look into these differences on a super high level. If you look at Azure database for SQL, this is a fully managed service. It simplifies data management with automated backup, patching and monitoring, built-in high availability with automatic failover, advanced threat protection encryption is default. It can be easily scalable with multiple compute and storage resources independently, and this is commonly used for web application like WordPress, e-commerce platforms, and content management system. The community which support this is the strong MySQL developer community, and extensive documentation is available. If you look at the Azure database for PostgreSQL, this offers supports for advanced data types and extensions such as PostGIS and geospatial data. It uses the hyperscale. It enables horizontal scaling. We talked about that. It accepts complex queries. This excels in handling complex queries and large data sets. This also offers advanced security features including encryption, virtual network service endpoint, and threat protection. Additionally, this provides built-in high availability and disaster recovery options. This is typically useful for analytics, geospatial application, and complex transactional application. The community support here is leveraging the robust PostgreSQL community and comprehensive features like PostGIS.